Fibonacci series. Fibonacci series is an extremely important series which behaves in this pattern fn equivalent to fn minus 1 plus fn minus 2 n greater than or equivalent to 3. This is the Fibonacci series pattern fn equivalent to fn minus 1 plus fn minus 2. That means if n is 3, f3 is nothing but f2 plus f1, f4 is nothing but f3 plus f2, f5 is nothing but f4 plus f3, and so on and so on. So Fibonacci series, if it is f1 equivalent to 1, f2 equivalent to 2, first two values will be given, f1 equivalent to 1 or f2 equivalent to 2. So f3 will become 1 plus 2, it is nothing but 3. f4 will become 3 plus 2, it is nothing but 5. f5 is nothing but 5 plus 3, 8. f6 is nothing but 8 plus 5, 13. f7 is nothing but 21, and so on. So first value it will be 1, second value it is 2, 1 plus 2 it is 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13, 13 plus 8 21, 21 plus 13 34, and so on. This is nothing but the most popular Fibonacci sequence. Fibonacci sequence or series which starts with 1, f1 1, f2 2, f3 3, f4 5, f5 8, f6 13, 21, 34, and so on. This series is called the Fibonacci series. Fibonacci series is of the pattern fn equivalent to fn minus 1 plus fn minus 2, n greater than or equivalent to 3, n greater than or equivalent to 3. What is its real-time application? First we will write down the Fibonacci sequence fn equivalent to fn minus 1 plus fn minus 2, n greater than or equivalent to 3. So 1 2, 1 plus 2 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13, 13 plus 8 21, 21 plus 13 34, again 55, 18 9, 144, and so on and so on. The best thing is right where it is used. In Fibonacci sequence has got varied applications. One important application is converting miles into kilometers. Converting miles into kilometers. Now if you see here, the smallest value is nothing but miles. Smallest value is nothing but miles. Immediate next highest value is nothing but kilometers. It is nothing but kilometers. For example, 5 miles is nothing but what is the next value? It is nothing but 8 kilometers. 5 miles is 8 kilometers. So 1 mile is close to 1.6 kilometers. Similarly, 8 miles is nothing but next immediate value is 13 kilometers. Similarly, 13 miles is nothing but 21 kilometers. 21 miles is nothing but 34 kilometers. The beautiful conversion. In fact, these Fibonacci series fn is nothing but 1.618 into fn minus 1. This 1.618 is called the golden ratio. It is called the golden ratio. As the value increases, 8 by 5, it is close to 1.6. 13 by 8, again it is close to 1.6. 21 by 13, again it is close to 1.6. So the ratio between two consecutive values, it is nothing but the golden ratio, and that ratio value is given by 1.618. Where this Fibonacci series is applied, one application is converting miles into kilometers. Smallest value is nothing but representation of miles, and the largest value is nothing but representation of kilometers. This is one application. There are various structures that can be defined by using Fibonacci applications. By using Fibonacci applications, Fn equivalent to 1.618 into Fn minus 1. Fn minus 1. Now see here, where it can be solved in counting related problems. First one, please write down. First question, question number 1. Question number 1, please write down. A person can climb a staircase. A person can climb a staircase using 1 or 2 steps at a time. Using 1 or 2 steps at a time. Using 1 or 2 steps at a time. In how many ways? Listen carefully, sir. All these counting related problems you can solve it very easily by using this Fibonacci series. In how many ways can he climb? In how many ways can he climb 10 steps using 1 or 2 steps only? Using 1 or 2 steps only. Listen carefully. Entire class, it is based on Fibonacci series. A person can climb a staircase using 1 or 2 steps. In how many ways can he climb 10 steps using 1 or 2 steps only? Now see the solution. First step it can be done by using 1. 2 steps he can do by using either 1 step or 2 steps. So it can be 1 plus 1 or it can be 2. Suppose if it is 3 steps. 3 steps it is nothing but only by using 1 plus 1 plus 1 or 1 plus 2 or it is 2 plus 1. That's all. 3 cannot be used. He got only 1 step and 2 steps. Now if you observe, this value is nothing but 1. This value is nothing but 2. This value it is nothing but 3. This value is nothing but 3. Suppose if I take 4 steps it is nothing but 1 plus 1 plus 1 plus 1 or 1 plus 2 plus 1. This can be arranged in 3 factorial by 2 factorial, which is 3 ways, and it can also be by using 2 plus 2, which is 4. 3 plus 1 plus 1, which is nothing but 5 ways. So if you observe, the 1 step can be done in 1 way, 2 steps can be done in 2 ways, 3 steps can be done in 3 ways, 4 steps can be done in 5 ways. This is nothing but a Fibonacci series. In Fibonacci series, how many I require? I require 10 steps. So these is nothing but F1. These is nothing but F2. These F3 and it is F4. Next will be 8. Next it is 13. Next 21. Next 34. Next 55. 18, 9. So these is nothing but F5. These F6. These F7. These F8. These F9 and it is F10. In how many ways can he reach 10 steps? It is nothing but 89 ways are there using 1 or 2 steps. Very, very good question. By using Fibonacci series, we can solve the question very, very easily. Only 1 step it is in 1 way. 2 steps by using 1 or 2 steps is 1 plus 1 and 2. 3 steps it will be 1 plus 1 plus 1, 1 plus 2, 2 plus 1. 4 steps it is 4 ones, 1 plus 2 plus 1 and 2 plus 2. 5 steps and so on. So 10 steps it will be 89. 10 steps it will be 89. But in the examination, in your examination, instead of 1 or 2 steps, he has given you the question with a slight twisting. A person can climb 8 steps. A person can climb 8 steps. In how many ways? In how many ways can he climb using 1 or 2 or 3 steps? This is the question. Using 1 or 2 or 3 steps only. By using 1 or 2 or 3 steps, in how many ways can a person can climb 8 steps? Now see here. Listen carefully, sir. A person can climb 8 steps. In how many ways he can using? 1 or 2 or 3 steps only. 1 step, only one way. 2 steps using 1 or 2 or 3 steps. So it can be 1 plus 1 or it can be 2. Suppose if it is 3 steps he can do by using 1 plus 1 plus 1 or 1 plus 2 or it is 2 plus 1 or it is nothing but 3 or it is nothing but 3. These is nothing but only one way. These is nothing but 2 ways. These is nothing but 1, 2, 3, 4. 4 ways. Suppose if it is 4 steps. 4 steps how he can do? 1 plus 1 plus 1 plus 1. 4 steps. Or he can use by using 2 plus 2. Or he can use by using 1 plus 1 plus 2. 1 plus 1 plus 2, 3 factorial by 2 factorial, which is 3 ways I will get. Here it is 1 way, here it is 1 way. Or he can use 3 plus 1 or 1 plus 3. 3 plus 1 or 1 plus 3. So here it is nothing but 2 ways. 3 plus 2, 5, 5 plus 2, 7. 5 plus 2, 7. So if you observe, it is nothing but Fn is nothing but Fn minus 1 plus Fn minus 2 plus Fn minus 3. Sum of the previous 3, it is nothing but the current value. So first it is 1, next it is 2, next 4, next it is the sum of all the previous 3. 1 plus 2 plus 4 is 7. Next it is 11 plus 2, it is nothing but 13. Next it is nothing but 24. Next it is nothing but 24, 13, 37, 37 plus 7. 44. Next it is nothing but 44 plus 24, 68, 68 plus 13, which is 18. How many? 8 steps we require. These is nothing but F1. These is nothing but F2. These is nothing but F3. These F4. And it is F5. Here it is F6. Here it is F7 and here it is F8. In how many ways can a person can climb 8 steps in by using 1, 2 or 3 steps? It is nothing but Fn equivalent to Fn minus 1 plus Fn minus 2 plus Fn minus 3. I hope the idea it is clear, right? Just read the question, see the behavior of 1 step, 2 steps, 3 steps and 4 steps. You will understand the pattern. I hope it is clear. It is sum of the previous 3 values. It is nothing but the sum of the previous 3 values. Second question, I hope it is clear. Third question. Third question, a small class solving only the problems based on Fibonacci series. A coin is tossed. A coin is tossed 10 times. A coin is tossed 10 times. How many ways exist? How many ways exist such that? How many ways exist such that no 2 consecutive heads appear? Such that no 2 consecutive heads appear. No 2 consecutive heads appear. A coin is tossed 10 times. How many ways exist such that no 2 consecutive heads appear? Beautiful question, sir, where counting can be avoided. Suppose if I toss a coin once. If I toss a coin once. If I toss a coin once, either I will get head or tail. Head or tail. 2 ways I got. 2 ways. Suppose if I toss a coin twice. If I toss a coin twice, I will get either head or tail or head head or tail tail, tail tail or head tail, right? So these are nothing but, head head, head tail and tail head. These are the 4 ways. No 2 consecutive heads appear. That means headed cannot appear. These are nothing but 3 ways. Tossing a coin. Suppose if I toss a coin thrice. If I toss a coin thrice. Now see here. These, if it is head. Next it is tail. No 2 consecutive heads appear. So these nothing but after h won't appear, after h t. So with t can come, with t h can come. Are you all with me? Suppose if it is th, no two consecutive heads appear. That means hh cannot appear. This can be t. This can be t. Similarly, if it is tt, the third choice can be either head or tail. 1, 2, 3, 4, 5. Tossing a coin thrice. So how many I got? 5. So first one it is 2. Second one it is 3. Third one it is 5. Total 10 times I require. Next one 8. Next one 13. Next one 21. Next is 34. Next is 55. Next is 89. And next is 144. These tossing a coin once. These tossing a coin twice. Tossing a coin thrice. These F4, these nothing but F5, these F6, these nothing but F7, these F8, and it is F9, and it is F10. So in how many ways exists such that no two consecutive heads appear? Answer is nothing but 144. Another beautiful application of Fibonacci series. Another beautiful application of Fibonacci series. I hope the idea it is clear. I hope the idea it is clear. Tossing a coin only once, head or tail, two ways. Tossing a coin twice, HH, TT, HT and TH. HH should not appear because the question is no two consecutive heads appear. HH is cancelled. It is nothing but 3. Tossing a coin thrice. The first time it can be head. Second time it cannot be head because no two consecutive heads appear. HT. With T it can be T. With T it can be H. With T it can be H. With T it can be T. So first time it can be either head or tail. So if it is head, next cannot be head. So it is T. With T, next can be head or tail. Total 5 cases. Another beautiful application of Fibonacci series. I hope the idea it is clear. Next. Suppose there is a set 1, 2, 3 and so on up to 10. How many subsets of A can be formed? How many subsets of A can be formed with no two consecutive elements in the subset? With no two consecutive elements in the subset. Please write down this question, sir. How many subsets of A can be formed with no two consecutive elements in the subset? No two consecutive elements in the subset. There is a set, it seems, which contains the values 1, 2, 3 and so on up to 10. How many subsets of A can be formed? Suppose if I take one element, 1, either I will get 5. No element, or I will get only one element. Two ways are there. Suppose if I take two elements, 1, 2, either I will not pick any element, or I will pick only one, or I will pick only 2. Suppose it is 1, 2. No two consecutive elements. These are not possible. So answer is nothing but 3. Answer is nothing but 3. Next one. 1, 2, 3. 1, 2, 3. No element 5. Only 1. Only 2. Only 3. 1, 2. Should I take this case? This case should not be taken. 1, 3. They are not consecutive. This can be taken. Next it is 2, 3. 2, 3. 2, 3 cannot be taken. 2, 3. Next it is nothing but total 3 elements are there. 2 power 3, 8 will come. 1, 2, 3, 4, 5, 6, 7. Next is nothing but 1, 2, 3. 1, 2, 3 are consecutive. This cannot be chosen. So 1, 2, 3, 4, 5. These is nothing but 5. Here it is nothing but 2. Here it is 3. Here it is 5. Now it is a Fibonacci series application. 2, 3, 5. 5, 8, 13, 21, 34, 55, 89, and it is 144. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So answer is nothing but 144. Another beautiful question. Answer is nothing but 144. Idea it is clear, right? I hope the idea it is clear. 1 means one element is there. How many number of subsets can be formed? 2 power n. N is the number of elements. N is the number of elements. N is the number of elements. So 5 and 1, 2 cases. 1 comma 2, 2 elements are there. 2 square it is 4. No element, single element and 2 elements. No 2 consecutive elements. So it is 1 comma 2 is eliminated. 1, 2 and 3. Here 1 comma 2 is consecutive. 2 comma 3 is consecutive. 1 comma 2 comma 3 is consecutive. So answer is nothing but 144. Answer is nothing but 144. Right? Where is the confusion? Suppose if a coin is tossed thrice. If a coin is tossed thrice, only once how many I got? Either head or tail. I got 2 cases. Twice how many I got? These is nothing but HT, TT, TH and HH. No 2 consecutive heads appear. These is nothing but 3. Coin tossed thrice, I should get 5 ways. I am getting 5 ways, right? First case can be head. So next it can be T. If it is T, HTT, HTH. Suppose if it is T, TTT. Next it can be TTH. Next it is TH, THT. So no 2 consecutive heads appear. There are no 2 consecutive heads. 1, 2, 3, 4, 5. I got 5, right? Coin tossed thrice is 5. Naveen, I think there is no confusion. I hope it is clear. Answer for this question is again a Fibonacci series application. Fibonacci series application. Next one. A building has 10 floors. A building has 10 floors. A building has 10 floors. Each floor can be colored. Each floor can be colored using blue or green. Using blue or green. In how many ways? In how many ways can you color this building? In how many ways can you color this building? In how many ways can you color this building such that no 2 consecutive floors, such that no 2 consecutive floors has the same green color? Another variety. No 2 consecutive floors has the same green color. All are easy questions if you understand the concept of Fibonacci series. A building has 10 floors. Each floor can be colored using blue or green. There is a building with 10 floors, F10. Here it is F9, floor 9. Here it is floor 8, floor 7, and so on up to floor 1. Each floor can be colored using blue or green. So first floor, I can do it either by using blue or green. Second floor. First floor, there are 2 ways. In how many ways can you color the building such that no 2 consecutive floors has the same green color? Down it is blue. So I can do blue, I can do green. Right? Down it is green. It cannot have same green color. It cannot have same green color. So it will be blue. It will be blue. If the down floor, if it is blue, there are 2 options, blue or green. If the down floor it is green, there is only one option. So GBB, how many cases? 3. Similarly, with G, second, F3, I will get 1 case. B, I will get BRG. Here I will get BRG. How many cases I got? 5. So these is nothing but 2. Next it is 3. Next it is 5. 8, 13, 21, 34, 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So F10, totally 10 floors can be colored in how many ways? 144 ways. Totally 10 floors can be colored in how many ways? 144 ways. I hope this is clear. Idea it is clear, right? 2, 3, 4, right? 21, 34, 55 and 89 and 144. Another question. How many 5-digit numbers? How many 5-digit numbers can be formed? How many 5-digit numbers can be formed using the digits? Using the digits 1, 2, 3 with no two consecutives. With no two consecutive twos. How many 5-digit numbers can be formed using the digits 1, 2, 3 with no two consecutive twos? With no two consecutive twos should not be there. Again the same approach. Suppose if it is a single digit number. If it is a single digit number, how many ways are there? 1, 2 or 3. 1, 2 or 3. Suppose if it is a 2-digit number. If it is a 2-digit number. So let me take here it is 1, 2 or 3. 1, 2 or 3. If it is 1, this can be also be 1. This can also be 2. This can also be 3. I hope it is clear. 2 consecutive 2 should not be there. This can also be 1. This can also be 3. This can also be 3. This can also be 1. This can also be 2. So how many ways we got? 1, 2, 3, 4, 5, 6, 7, 8. 2 digits totally 8 cases we got. Here it is 3 cases. This is a single digit number. This is a single digit number. And this is a 2-digit number. This is a 2-digit number. Suppose if I want a 3-digit number. If I want a 3-digit number. For 1 there are 3 cases. 1, 2 and 3. For 2 there are 2 cases. What are that cases? 1 and 3. For 3 there are 3 cases. 1, 2 and 3. 1, 2 and 3. That means here it is 3 cases. Here 2 cases. Here 3 cases. So for 3 digits how much we got? 3 plus 2 plus 3. 3 plus 2 plus 3. I hope it is clear, right? Similarly, here again for 3, how many cases we got? 1, 2 and 3. 1, 2 and 3. Here it is 1 and 3. Here it is 1, 2 and 3. Here it is consecutive 2s, it should not appear, right? So here it will be 1, 2 and 3. And here it will be 1, 2 and 3. Just to count the cases and check the pattern. How many it is getting? Just to check it out. Now 1 minute, sir. I'll do it little neatly. How many 5-digit numbers? How many 5-digit numbers using the digits 1, 2, 3 with no 2 consecutive 2s? With no 2 consecutive 2s. This is the question. With no 2 consecutive 2s. Single digit number. If it is a single digit number, this will be 1, 2 or 3. If it is a 2-digit number, no 2 should appear. So that means here it can be 1. Here it can be 2. Here it can be 3. Here it can be 1. Here it can be 3. Here it can be 1. Here it can be 2. Here it can be 3. So totally for this I got 3 cases. For this I got 3 plus 2, 5, 5 plus 3, 8 cases. If it is for 3 digits. If it is for 3 digits. For 1, it can be 1, 2 or 3. For 2, it can be 1 or 3. For 3, it can be 1, 2 or 3. 1, 2 or 3. Here also I will get 3 cases. Here also I will get 3 cases. Here 1, I will get 3 cases. For 2, I will get 2 cases. For 3, I will get 3 cases. So here it is 3 cases. Here it is 2 cases. Here it is 3 cases. These are nothing but 3 plus 2, 5. 5 plus 3, 8. 8 plus 3, 11. 14, 17, 20, 22. 17, 20, 22. So these are nothing but S1 plus S2 into 2. It is nothing but S3. S1 plus S2 into 2. I hope it is clear, right? So S3 is 3, 8. 8 plus 3, 11. 11 2s are 22. Again, 22 plus 8, 30. 30 2s are, it is 60. 60 plus 22, 82. 82 2s are 164. Answer for this question is nothing but 164. This is behaving of the pattern. Sn is nothing but 2 into Sn minus 1 plus Sn minus 2. Sn minus 1 plus Sn minus 2. I hope it is clear. Sn minus 1 plus Sn minus 2. Idea it is clear, right? Fibonacci series, or how to understand the patterns of these particular problems. Sn equivalent to 2 into Sn minus 1 plus Sn minus 2. 2 into Sn minus 1 plus Sn minus 2. Let me see if there are any other good questions that are missing under these pattern. Under these pattern, let us see if I missed out any questions, right? Next one. Please try to solve one more question. How many 10-digit numbers? How many 10-digit numbers can be formed? How many 10-digit numbers can be formed using the digits 1, 2? How many 10-digit numbers can be formed using the digits 1, 2 with no 2 consecutive ones? Please try to solve, sir. Same pattern with no 2 consecutive ones. With no 2 consecutive ones. How many 10-digit numbers can be formed using the digits 1, 2 with no 2 consecutive ones? First we will do single digit. First we will do single digit. Single digit, it is nothing but 1, 2. 2 ways are there. No 2 consecutive ones. If it is 2-digit numbers, 2 ones should not appear. So with 1 it can be 2. With 2 there are 2 ways. 1, 2. Total how many ways are there? 3 ways are there. With 3-digit numbers. 3-digit numbers. With 2 I will get 2 wings. 1 and 2. With 1 I will get 2. With 2 I will get 1, 2. Here it is 5. Again it is a Fibonacci series. 2, 3, 5, 8, 13, 21, 34, 55, 18, 9 and 144. I want a 10-digit number. F1. Here it is F2. Here it is F3, F4, F5, F6, F7, F8, F9 and it is F10. So answer for this question is nothing but 144. Answer for this question is nothing but 144. I hope the idea it is clear, right? Single digits, 2 digits and 3 digits. Just by observing few patterns, you will understand that this is using Fibonacci series. Fn is nothing but Fn minus 1 plus Fn minus 2. Fn minus 2. Fn equivalent to Fn minus 1 plus Fn minus 2. Not only this, right? You can also solve problems like this. Suppose there is a series 1, 2, 3, 4, 5 till 20. Right? 4 numbers should be selected. 4 numbers should be selected from the set. 4 numbers should be selected from the set. such that they are in arithmetic progression. Such that they are in arithmetic progression. D is not equivalent to 0. I need to select 4 distinct numbers from the set such that they are in arithmetic progression. D not equivalent to 0. D is not equivalent to 0. 1, 2, 3, 4, 5 till 20. 1, 2, 3, 4, 5 till 20. Method number 1. 3 numbers already we have seen. 2b is equivalent to a plus c. So, if method number 1, if D common difference it is 1, 4 numbers I need to choose. 1 is 1, 2, 3, 4. Am I right? Next is nothing but 2, 3, 4, 5. Am I right? Again difference is 1 and so on up to 17, 18, 19, 20. All these numbers will have D value 1. So, D value 1 how much I got? 17. Next one D value 2. If D value 2, if it is there, 1, 3, 5, 7. 1, 3, 5, 7. Next it is nothing but 2, 4, 6, 8. 2, 4, 6, 8. And it goes on up to 14, 16, 18, 20. So from 1 to 14, how many numbers we got? 14 numbers we got. If D value, if it is 3. If D, if it is 3. 1, 4, 7, 10. 1, 4, 7, 10. Next it can be 2, 5, 8, 11. 2, 5, 8, 11. Next it will be, for example, 11, 3 increase. 3 means 14, 17, 20. So here it is nothing but 11. That means the difference is 3. So answer is nothing but 17 plus 14 plus 11. Again 3 decrease. Again 3 decrease. Again 3 decrease. This is the answer. 17 plus 14 plus 11 plus 8 plus 5 plus 2. Once you understand the pattern, it will be very, very easy. Now directly you can write it. Totally how many numbers are there? 20. How many numbers I have to pick? 4. These is nothing but 20 minus 4 plus 1. These is nothing but 20 minus 4 plus 1. 20 minus 4 is 16. 16 plus 1 is 17. Because I need to check 4 numbers. 4 numbers will have 3 gaps. So every time there is a gap of 3. Every time there is a gap of 3. Directly you can write it as 17, 14, 11. 3 decrease, 3 decrease, 3 decrease. 2, 5, 8, 11, 14 and 17. I hope the idea it is clear. Now you can solve any question based upon this model very, very fast. Suppose if it is 1, 2, 3, 4, 5 and so on up to 40. 5 numbers are selected. 5 numbers are selected. I need to select 5 numbers such that they are in arithmetic progression. Such that they are in arithmetic progression. What will be the answer? 40 minus 5. 35 plus 1. 36. 5 numbers means there will be 4 gaps. 36, 32, 28, 24. 4 nines are 36. Here it will go on up to 4 ones are 4. 4 ones are 4. I hope it is clear. So answer is nothing but 9 by 2 into 36 plus 4. 9 by 2 into nothing but 40, which is nothing but 180. Total, in how many ways can you select 5 numbers such that they are in arithmetic progression? 36, 32, 28, 24 and so on up to 4. 4 ones are 42, 4 nines are 36. 9 by 2 into 36 plus 4. 9 by 2 into 40, it is nothing but 180. I hope it is